Hey everybody. Today we're doing some problems using the normal distribution. All the problems we're going to do are going to relate to this situation. Suppose the annual per capita consumption of oranges in the United States is approximately normal, with mean 9.1 pounds and standard deviation 2.7 pounds. Here are the three questions that I'm going to tackle. My recommendation is that you pause the video here, try these problems, and then come back and look at my solutions after you've worked on them for a little bit. Problem 1. What's the z-score of a person that consumes 8 pounds of oranges per year? And what is their percentile? So let's do the z-score first. In order to compute a z-score, we take the value we've got, 8.0, subtract off the mean of the distribution, 9.1, and then divide by the standard deviation, 2.7. We do that arithmetic, we get negative 0.41. So an individual that consumes 8 pounds of oranges per year consumes fewer oranges than average. They are 0.41 standard deviations below the mean consumption of oranges in the United States. That individual consuming 8 pounds of oranges per year consumes more than about 34% of the population. And the picture is shown here. So what I've done is I've drawn the normal distribution with mean 9.1 and standard deviation 2.7, so variance 2.7 squared. I've labeled 8.0, that's a little bit less than average, as we noticed a moment ago. And what I'm trying to do is to compute the area to the left of 8.0 under this graph. And that's most easily done using technology. I'm using R, where the cumulative distribution function is p-norm. So p-norm 8.0, 9.1, 2.7 corresponds exactly to the shaded area shown there. And it's about 34%. We can also find the percentile using the z-score that we found a moment ago, negative 0.41. Because the probability of getting a random value less than 8.0 in the normal distribution we're talking about here is exactly the same as the probability of getting a random z-score less than or equal to negative 0.41, the z-score corresponding to x equals 8.0 in the original distribution. And we can do that using the CDF of the standard normal distribution, which in R is p-norm with no other parameters, just the value that we're interested in, p-norm of negative 0.41. Again, we get 34%. Problem 2. What's the probability that a randomly selected person consumes between 8 and 10 pounds of oranges per year? So what I'm trying to do here is to compute this shaded area. I've drawn the same bell curve as before, labeled 8 and 10. The shaded area is representing the probability that someone is in that range. So I'm going to do this again using the CDF of this normal distribution, which in R is p-norm. I'm going to take the area to the left of 10 and then subtract off the area to the left of 8. P-norm of 10.0, 9.1, 2.7, minus P-norm of 8.0, 9.1, 2.7. I do that arithmetic, I get about 29%. Problem 3. If an American eats less than 85% of their peers, how much do they consume? So, again, I'm drawing a bell curve, same as before, same bell curve as before. Only now, instead of being given a value and being asked to compute a probability, now I'm given a probability, a percentage, a percentile, and being asked to compute a value. So I'm going to want to use an inverse normal calculation. Now an inverse normal calculation wants to take a probability or an area to the left, not to the right. And I'm given the area, the probability, to the right is 85%. So the very first thing I do is I figure out that if 85% is to the right, then 15% is to the left. So this is the value I need to feed my inverse normal calculation. In R, that's coded with the qnorm command. Qnorm of 0.15, 9.1, 2.7 is going to give me the x value that has 15% of the area to the left, 15% of the probability to the left in the normal distribution with mean 9.1 and standard deviation 2.7. The result is 6.3, so an American that eats 6.3 pounds of oranges per year consumes less than 85% of their peers.